Working from a finished and verified schematic design, we are now going to add a PCB board to the project. Once in place, we will check the units and grid settings first before manipulating the board profile. Opening the Cartesian grid from the grid dialog, we see its settings. The coarse grid is a multiple of 5 fine grid units. Here we see the coarse grid in pink around a 5x5 fine grid. The first method we are going to review for redefining the board profile shape is Redefine Board Shape from the Board Shape Options drop-down. This allows the complete board profile to be drawn using the standard drawing tools. Corners can be changed in style through Shift plus Spacebar, which cycles through the styles. Hotkeys are used to manipulate the profile. The second method is using Edit Board Shape, which allows change through drag of profile edges and grips. Note how the grid area expands, contracts accordingly. The third method is to use primitives through Create Primitives from Board Shape, which forms non-net lines and arcs on a layer for editing. Here, placed on a mechanical layer called Outline. These lines and arcs can be altered, removed and added. Here, after an adjustment on the corner segment, we will add a bulge into the side of the profile, ensuring the final singular shape is continuous. When inside a function, pressing the Tab key opens its properties, which allows for defining its settings before use. Adjusting the upper endpoint of the vertical line allows for the correct portion of it to be removed. Once the shape is how the profile is to be, it is all selected and Define from selected objects creates the new board profile. Note that the shape is just a shape and not the board profile, so the shape can be removed from view or even deleted. The fourth and most accurate method is to use collaboration with SOLIDWORKS MCAD. The board is pushed to SOLIDWORKS to create an assembly. Here, setting the board part in Edit, we can manipulate its form and then return the results to SOLIDWORKS PCB. A huge advantage is that the profile can be accurately defined for its future position in upper assemblies. After pushing back, the proposed changes can be reviewed before acceptance. Now we will pull the design intent from the schematic design into the PCB through ECO action. Note that on validation, the system cannot find some footprints, a situation to be resolved, but does not stop the execution of other update changes. An ECO report can be produced and saved for the project.